6 of Cosmos, a sketch of the physical description of the universe, Introduction, by Alexander von Humboldt. This LibriVox recording is in the public domain. The effects that may arise from the specific difference and the heterogeneous nature of matter have not hitherto entered into our calculations of the mechanism of the heavens. The only means by which the inhabitants of our planet can enter into relation with the matter contained within the regions of space, whether existing in scattered forms or united into large spheroids, is by the phenomena of light, the propagation of luminous waves, and by the influence universally exercised by the force of gravitation or the attraction of masses. The existence of a periodical action of the sun and moon on the variations of terrestrial magnetism is even at the present day extremely problematical. We have no direct experimental knowledge regarding the properties and specific qualities of the masses circulating in space, or of the matter of which they are probably composed, if we accept what may be derived from the fall of aerolites or meteoric stones, which, as we have already observed, enter within the limits of our terrestrial sphere. It will be sufficient here to remark that the direction and the excessive velocity of projection, a velocity wholly planetary, manifested by these masses, render it more than probable that they are small celestial bodies, which, being attracted by our planet, are made to deviate from their original course, and thus reach the earth enveloped in vapors and in a high state of actual incandescence. The familiar aspect of these asteroids and the analogies which they present with the minerals composing the earth's crust undoubtedly afford ample grounds for surprise. But in my opinion, the only conclusion to be drawn from these facts is that, in general, planets and other sidereal masses, which by the influence of a central body have been agglomerated into rings of vapor, and subsequently into spheroids, being integrant parts of the same system, and having one common origin, may likewise be composed of substances chemically identical. Again, experiments with the pendulum, particularly those prosecuted with such rare precision by Bessel, confirm the Newtonian axiom that bodies the most heterogeneous in their nature, as water, gold, quartz, granular limestone, and different masses of aerolites, experience a perfectly similar degree of acceleration from the attraction of the earth. To the experiments of the pendulum may be added the proofs furnished by purely astronomical observations. The almost perfect identity of the mass of Jupiter, deduced from the influence exercised by this stupendous planet on its own satellites, on Encke's comet of short period, and on the small planets Vesta, Juno, Ceres, and Pallas, indicates with equal certainty that within the limits of actual observation, attraction is determined solely by the quantity of matter. This absence of any perceptible difference in the nature of matter, alike proved by direct observation and theoretical deductions, imparts a high degree of simplicity to the mechanism of the heavens. The immeasurable extent of the regions of space being subjected to laws of motion alone, the sidereal portion of the science of the cosmos is based on the pure and abundant source of mathematical astronomy, as is the terrestrial portion on physics, chemistry, and organic morphology. But the domain of these three last named sciences embraces the consideration of phenomena which are so complicated and have, up to the present time, been found so little susceptible of the application of rigorous method, that the physical science of the earth cannot boast of the same certainty and simplicity in the exposition of facts and their mutual connection which characterize the celestial portion of the cosmos. It is not improbable that the difference to which we allude may furnish an explanation of the cause which in the earliest ages of intellectual culture among the Greeks directed the natural philosophy of the Pythagoreans with more ardor to the heavenly bodies and the regions of space than to the earth and its productions, and how, through Philolaus, and subsequently through the analogous views of Aristarchus of Samos and of Seleucus of Erythea, This science has been made more conducive to the attainment of a knowledge of the true system of the world than the natural philosophy of the Ionian school could ever be to the physical history of the earth. Giving but little attention to the properties and specific differences of matter filling space, the great Italian school, in its Doric gravity, turned by preference toward all that relates to measure, to the form of bodies, and to the number and distances of the planets, while the Ionian physicists directed their attention to the qualities of matter, its true or supposed metamorphoses, and to relations of origin. It was reserved for the powerful genius of Aristotle, alike profoundly speculative and practical, to sound with equal success the depths of abstraction and the inexhaustible resources of vital activity pervading the material world. Several highly distinguished treatises on physical geography are prefaced by an introduction whose purely astronomical sections are directed to the consideration of the earth in its planetary dependence, and as constituting a part of that great system which is animated by one central body, the sun. This course is diametrically opposed to the one which I propose following. In order adequately to estimate the dignity of the cosmos, it is requisite that the sidereal portion, termed by Kant the natural history of the heavens, should not be made subordinate to the terrestrial. In the science of the cosmos, according to the expression of Aristarchus of Samos, the pioneer of the Copernican system, the sun with its satellites was nothing more than one of the innumerable stars by which space is occupied. The physical history of the world must therefore begin with a description of the heavenly bodies, and with a geographical sketch of the universe, or, I would rather say, a true map of the world, such as was traced by the bold hand of the elder Herschel. If, notwithstanding the smallness of our planet, the most considerable space and the most attentive consideration be here afforded to that which exclusively concerns it, this arises solely from the disproportion to the extent of our knowledge of that which is accessible, and of that which is closed to our observation. This subordination of the celestial to the terrestrial portion is met with in the great work of Bernard Varenius, which appeared in the middle of the 17th century. He was the first to distinguish between general and special geography, the former of which he subdivides into an absolute, or properly speaking, terrestrial part, and a relative or planetary portion, according to the mode of considering our planet, either with reference to its surface in its different zones, or to its relations to the sun and moon. It redounds to the glory of Varenius that his work on general and comparative geography should in so high a degree have arrested the attention of Newton. The imperfect state of many of the auxiliary sciences from which this writer was obliged to draw his materials prevented his work from corresponding to the greatness of the design, and it was reserved for the present age, and for my own country, to see the delineation of comparative geography drawn in its full extent, and in all its relations with the history of man, by the skillful hand of Carl Ritter. The enumeration of the most important results of the astronomical and physical sciences, which in the history of the cosmos radiate toward one common focus, may perhaps to a certain degree justify the designation I have given to my work, and considered within the circumscribed limits I have proposed to myself, the undertaking may be esteemed less adventurous than the title. The introduction of new terms, especially with reference to the general results of a science, which ought to be accessible to all, has always been greatly in opposition to my own practice, and whenever I have enlarged upon the established nomenclature, it has only been in the specialties of descriptive botany and zoology, where the introduction of hitherto unknown objects rendered new names necessary. The denominations of physical descriptions of the universe, or physical cosmography, which I use indiscriminately, have been modeled upon those of physical descriptions of the earth, that is to say, physical geography, terms that have long been in common use. Descartes, whose genius was one of the most powerful manifested in any age, has left us a few fragments of a great work, which he intended publishing under the title of Monde, and for which he had prepared himself by special studies, including even that of human anatomy. The uncommon but definite expression of the science of the cosmos recalls to the mind of the inhabitant of the earth that we are treating of a more widely extended horizon, of the assemblage of all things with which space is filled, from the remotest nebulae to the climatic distribution of those delicate tissues of vegetable matter which spread a variegated covering over the surface of our rocks. The influence of narrow-minded views peculiar to the earlier ages of civilization led in all languages to a confusion of ideas in the synonymic use of the words earth and world, while the common expressions voyages around the world, map of the world, and new world afford further illustrations of the same confusion. The more noble and precisely defined expressions of system of the world, the planetary world, and creation and age of the world, relate either to the totality of the substances by which space is filled, or to the origin of the whole universe. It was natural that in the midst of the extreme variability of phenomena presented by the surface of our globe, and the aerial ocean by which it is surrounded, man should have been impressed by the aspect of the vault of heaven, and the uniform and regular movements of the sun and planets. Thus the word cosmos, which primitively in the Homeric ages indicated an idea of order and harmony, was subsequently adopted in scientific language, where it was gradually applied to the order observed in the movements of the heavenly bodies, to the whole universe, and then finally to the world in which this harmony was reflected to us. According to the assertion of Philolaus, whose fragmentary works have been so ably commented upon by Boeckh, and conformably to the general testimony of antiquity, Pythagoras was the first who used the word cosmos to designate the order that reigns in the universe, or entire world. From the Italian school of philosophy, the expression passed in this signification into the language of those early poets of nature, Parmenides and Empedocles, and from thence into the works of prose writers. We will not here enter into a discussion of the manner in which, according to the Pythagorean views, Philolaus distinguishes between Olympus, Uranus, or the heavens, and cosmos, or how the same word, used in a plural sense, could be applied to certain heavenly bodies, the planets, revolving around one central focus of the world, or the group of stars. In this work I use the word cosmos in conformity with the Hellenic usage of the term subsequently to the time of Pythagoras, and in accordance with the precise definition given of it in the treatise entitled De Mundo, which was long erroneously attributed to Aristotle. It is the assemblage of all things in heaven and earth, the universality of created things constituting the perceptible world. If scientific terms had not long been diverted from their true verbal signification, the present work ought rather to have borne the title Cosmography, divided into Uranography and Geography. The Romans, in their feeble essays on philosophy, imitated the Greeks by applying to the universe the term mundus, which in its primary meaning indicated nothing more than ornamental, and did not even imply order or regularity in the disposition of parts. It is probable that the introduction into the language of Latium of this technical term, as an equivalent for cosmos in its double signification, is due to Ennius, who was a follower of the Italian school, and the translator of the writings of Epicharmus and some of his pupils on the Pythagorean philosophy. We would first distinguish between the physical history and the physical description of the world. The former, conceived in the most general sense of the word, ought, if materials for writing it existed, to trace the variations experienced by the universe in the course of ages, from the new stars which have suddenly appeared and disappeared in the vault of heaven, from nebulae dissolving or condensing, to the first stratum of cryptogamic vegetation on the still imperfectly cooled surface of the earth, or on a reef of coral uplifted from the depths of ocean. The physical description of the world presents a picture of all that exists in space, of the simultaneous action of natural forces, together with the phenomena which they produce. But if we would correctly comprehend nature, we must not entirely or absolutely separate the consideration of the present state of things from that of the successive phases through which they have passed. We cannot form a just conception of their nature without looking back on the mode of their formation. It is not organic matter alone that is continually undergoing change and being dissolved to form new combinations. The globe itself reveals at every phase of its existence the mystery of its former conditions. We cannot survey the crust of our planet without recognizing the traces of the prior existence and destruction of an organic world. The sedimentary rocks present a succession of organic forms, associated in groups, which have successively displaced and succeeded each other. The different superimposed strata thus display to us the faunas and floras of different epochs. In this sense, the description of nature is intimately connected with its history, and the geologist who is guided by the connection existing among the facts observed can not form a conception of the present without pursuing through countless ages the history of the past. In tracing the physical delineation of the globe, we behold the present and the past reciprocally incorporated, as it were, with one another, for the domain of nature is like that of languages, in which etymological research reveals a successive development by showing us the primary condition of an idiom reflected in the forms of speech in use at the present day. The study of the material world renders this reflection of the past peculiarly manifest, by displaying in the process of formation rocks of eruption and sedimentary strata similar to those of former ages. If I may be allowed to borrow a striking illustration from the geological relations by which the physiognomy of a country is determined, I would say that domes of trachyte, cones of basalt, lava streams, coulées, of amygdaloid with elongated and parallel pores, and white deposits of pumice intermixed with black scoriae animate the scenery by the associations of the past which they awaken, acting upon the imagination of the enlightened observer like traditional records of an earlier world. Their form is their history. The sense in which the Greeks and Romans originally employed the word history proves that they too were intimately convinced that to form a complete idea of the present state of the universe it was necessary to consider it in its successive phases. It is not, however, in the definition given by Valerius Flaccus, but in the zoological writings of Aristotle, that the word history presents itself as an exposition of the results of experience and observation. The physical description of the word by Pliny the Elder bears the title of natural history, while in the letters of his nephew it is designated by the nobler term history of nature. The earlier Greek historians did not separate the descriptions of countries from the narrative of events of which they had been the theater. With these writers, physical geography and history were long intimately associated, and remained simply but elegantly blended until the period of the development of political interests, which the agitation in which the lives of men were passed caused the geographical portion to be banished from the history of nations and raised into an independent science. It remains to be considered whether, by the operation of thought, we may hope to reduce the immense diversity of phenomena comprised by the cosmos to the unity of a principle, and the evidence afforded by rational truths. In the present state of empirical knowledge, we can scarcely flatter ourselves with such a hope. Experimental sciences, based on the observation of the external world, cannot aspire to completeness. The nature of things and the imperfection of our organs are alike opposed to it. We shall never succeed in exhausting the immeasurable riches of nature, and no generation of men will ever have cause to boast of having comprehended the total aggregation of phenomena. It is only by distributing them into groups that we have been able, in the case of a few, to discover the empire of certain natural laws, grand and simple as nature itself. The extent of this empire will no doubt increase in proportion as physical sciences are more perfectly developed. Striking proofs of this advancement have been made manifest in our own day in the phenomena of electromagnetism, the propagation of luminous waves, and radiating heat. In the same manner, the fruitful doctrine of evolution shows us how, in organic development, all that is formed is sketched out beforehand, and how the tissues of vegetable and animal matter uniformly arise from the multiplication and transformation of cells. The generalization of laws, which, being at first bounded by narrow limits, had been applied solely to isolated groups of phenomena, acquires in time more marked gradations, and gains in extent and certainty as long as the process of reasoning is applied strictly to analogous phenomena. But as soon as dynamical views prove insufficient, where the specific properties and heterogeneous nature of matter come into play, it is to be feared that by persisting in the pursuit of laws, we may find our course suddenly arrested by an impassable chasm. The principle of unity is lost sight of, and the guiding clue is rent asunder whenever any specific and peculiar kind of action manifests itself amid the active forces of nature. The law of equivalence and the numerical proportions of composition, so happily recognized by modern chemists and proclaimed under the ancient form of atomic symbols, still remains isolated and independent of mathematical laws of motion and gravitation. Those productions of nature which are objects of direct observation may be logically distributed in classes, orders, and families. This form of distribution undoubtedly sheds some light on descriptive natural history. But the study of organized bodies, considered in their linear connection, although it may impart a greater degree of unity and simplicity to the distribution of groups, cannot rise to the height of a classification based on one sole principle of composition and internal organization. As different gradations are presented by the laws of nature according to the extent of the horizon or the limits of the phenomena to be considered, so there are likewise differently graduated phases in the investigation of the external world. Empiricism originates in isolated views, which are subsequently grouped according to their analogy or dissimilarity. To direct observation succeeds, although long afterward, the wish to prosecute experiments, that is to say, to evoke phenomena under different determined conditions. The rational experimentalist does not proceed at hazard, but acts under the guidance of hypotheses founded on a half indistinct and more or less just intuition of the connection existing among natural objects or forces. That which has been conquered by observation or by means of experiments leads by analysis and induction to the discovery of empirical laws. These are the phases in human intellect that have marked the different epochs in the life of nations, and by means of which that great mass of facts has been accumulated which constitutes at the present day the solid basis of the natural sciences. Two forms of abstraction conjointly regulate our knowledge, namely, relations of quantity, comprising ideas of number and size, and relations of quality, embracing the consideration of the specific properties and the heterogeneous nature of matter. The former, as being more accessible to the exercise of thought, appertains to mathematics. The latter, from its apparent mysteries and greater difficulties, falls under the domain of the chemical sciences. In order to submit phenomena to calculation, recourse is made to a hypothetical construction of matter by a combination of molecules and atoms, whose number, form, position, and polarity determine, modify, or vary phenomena. The mythical ideas long entertained of the imponderable substances and vital forces peculiar to each mode of organization have complicated our views generally, and shed an uncertain light on the path we ought to pursue. The most various forms of intuition have thus, age after age, aided in augmenting the prodigious mass of empirical knowledge, which in our own day has been enlarged with ever-increasing rapidity. The investigating spirit of man strives from time to time, with varying success, to break through those ancient forms and symbols invented to subject rebellious matter to rules of mechanical construction. We are still very far from the time when it will be possible for us to reduce, by the operation of thought, all that we perceive by the senses to the unity of a rational principle. It may even be doubted if such a victory could ever be achieved in the field of natural philosophy. The complication of phenomena and the vast extent of the cosmos would seem to oppose such a result. But even a partial solution of the problem, the tendency toward a comprehension of the phenomena of the universe, will not the less remain the eternal and sublime aim of every investigation of nature. In conformity with the character of my former writings, as well as with the labors in which I have been engaged during my scientific career, in measurements, experiments, and the investigation of facts, I limit myself to the domain of empirical ideas. The exposition of mutually connected facts does not exclude the classification of phenomena according to their rational connection, the generalization of many specialties in the great mass of observations, or the attempt to discover laws. Conceptions of the universe solely based upon reason and the principles of speculative philosophy would no doubt assign a still more exalted aim to the science of the cosmos. I am far from blaming the efforts of others solely because their success has hitherto remained very doubtful. Contrary to the wishes and counsels of those profound and powerful thinkers who have given new life to the speculations which were already familiar to the ancients, systems of natural philosophy have in our own country for some time past turned aside the minds of men from the graver study of mathematical and physical sciences. The abuse of better powers, which has led many of our noble but ill-judging youth into the saturnalia of a purely ideal science of nature, has been signalized by the intoxication of pretended conquests, by the novel and fantastically symbolical phraseology, and by a predilection for the formulae of a scholastic rationalism more contracted in its views than any known to the Middle Ages. I use the expression abuse of better powers because superior intellects devoted to philosophical pursuits and experimental sciences have remained strangers to these saturnalia. The results yielded by an earnest investigation in the path of experiment cannot be at variance with a true philosophy of nature. If there be any contradiction, the fault must lie either in the unsoundness of speculation or in the exaggerated pretensions of empiricism, which thinks that more is proved by experiment than is actually derivable from it. External nature may be opposed to the intellectual world, as if the latter were not comprised within the limits of the former, or nature may be opposed to art when the latter is defined as a manifestation of the intellectual power of man. But these contrasts, which we find reflected in the most cultivated languages, must not lead us to separate the sphere of nature from that of mind, since such a separation would reduce the physical science of the world to a mere aggregation of empirical specialties. Science does not present itself to man until mind conquers matter in striving to subject the results of experimental investigation to rational combinations. Science is the labor of mind applied to nature, but the external world has no real existence for us beyond the image reflected within ourselves through the medium of the senses. As intelligence and forms of speech, thought, and its verbal symbols are united by secret and indissoluble links, so does the external world blend almost unconsciously to ourselves with our ideas and feelings. External phenomena, says Hegel in his Philosophy of History, are in some degree translated in our inner representations. The objective world, conceived and reflected within us by thought, is subjected to the eternal and necessary conditions of our intellectual being. the activity of the mind exercises itself on the elements furnished to it by the perceptions of the senses. Thus, in the early ages of mankind, there manifests itself in the simple intuition of natural facts, and in the efforts made to comprehend them, the germ of the philosophy of nature. These ideal tendencies vary and are more or less powerful according to the individual characteristics and moral dispositions of nations, and to the degrees of their mental culture, whether attained amid scenes of nature that excite or chill the imagination. History has proved the record of the numerous attempts that have been made to form a rational conception of the whole world of phenomena, and to recognize in the universe the action of one sole active force by which matter is penetrated, transformed, and animated. These attempts are traced in classical antiquity, in those treatises on the principles of things which emanated from the Ionian school, and in which all the phenomena of nature were subjected to hazardous speculations based upon a small number of observations. By degrees, as the influence of great historical events has favored the development of every branch of science supported by observations, that ardor has cooled which formerly led men to seek the essential nature and connection of things by ideal construction and in purely rational principles. In recent times, the mathematical portion of natural philosophy has been most remarkably and admirably enlarged. The method and the instrument, analysis, have been simultaneously perfected. That which has been acquired by means so different, by the ingenious application of atomic suppositions, by the more general and intimate study of phenomena, and by the improved construction of new apparatus, is the common property of mankind, and should not, in our opinion, now, more than in ancient times, be withdrawn from the free exercise of speculative thought. It cannot be denied that in this process of thought the results of experience have had to contend with many disadvantages. We must not, therefore, be surprised if, in the perpetual vicissitude of theoretical views, as is ingeniously expressed by the author of Giordano Bruno, most men see nothing in philosophy but a succession of passing meteors, while even the grander forms in which she has revealed herself share the fate of comets, bodies that do not rank in popular opinion among the eternal and permanent works of nature, but are regarded as mere fugitive apparitions of igneous vapor. We would here remark that the abuse of thought, and the false track it too often pursues, ought not to sanction an opinion derogatory to intellect, which would imply that the domain of mind is essentially a world of vague, fantastic illusions, and that the treasures accumulated by laborious observations in philosophy are powers hostile to its own empire. It does not become the spirit which characterizes the present age distrustfully to reject every generalization of views and every attempt to examine into the nature of things by the process of reason and induction. It would be a denial of the dignity of human nature and the relative importance of the faculties with which we are endowed, were we to condemn at one time austere reason, engaged in investigating causes and their mutual connections, and at another that exercise of the imagination which prompts and excites discoveries by its creative powers. End of Part 6. End of Cosmos, a sketch of the physical description of the universe, Introduction, by Alexander von Humboldt.